Start have an announcement from Dr. Kerstetter. So if you can give him your attention.
Appreciate the time. Good morning. Just wanted to update you folks. You probably have seen on Canvas that we have the 2 trips, Honduras and to Haiti. We are still needing students that may be interested in going to Honduras. I don't know if any of you know Erin Koyoka, who's a D4, or a young lady, maybe someone who had your big, Bella Padilla. She was on that trip last year to the Honduras trip. We have not been to Haiti since 2015. As far as the actual prices, I do not have that yet because again, we need to coordinate with Butler Travel to find out what the prices of the airfare for round trip and stuff is. But I'm guessing in around the 1,200, 1,300 or a little bit lower. Okay, so it's not going to be the 2,000, 2,100 price. It will be on the Friday. Both trips will be leaving on the Friday after test week. The Thursday is the last day of test week. Have a seat, have a seat. The last day of test week is Thursday. We plan to try and be flying out by the next day to both locations, and you will be back on that Sunday before school starts. Okay? Haiti people are concerned about the safety and the security of Haiti. Right now it is classified as A3, which is caution. But again, we've just recently had a team from the medical school that was there, and they had an incredible experience there. So again, at least for right now, and talking also with the physician, Adventist physician that lives in Florida, that is the coordinator of this, he says everything is in really good shape. So if any of you are interested, we also have a whole bunch of other things that you can get involved in. August 10th and 11th, we're going to be going to Coachella. I think you guys have seen that one also. It's $25 if you're going to go with them, but if you do not want to spend the night, you're welcome to ride with me in the motorhome about 5 o'clock a.m. Sunday morning, and we'll drive out there. Yes?
I tried to sign up for that one and it was full. I called Christy and she's supposed to look into it. She said she needed to talk to you.
It is full? Okay, let me go ahead and, yeah, I have not received anything from her, but I will look into it.
Okay.
Thank you for letting me know about that.
Okay.
Any other questions? Yes?
What specific place in Honduras?
It's actually Valle de Angeles. It's in the mountains. And I will try to catch another class period of yours because I have a short video of that trip if you folks want to see it, of that exact site. And it shows the bed and breakfast place, the hospital, and things. So we will do that, but I don't want to take up any more time. If you have any questions, feel free to come upstairs, 5th floor. What is that? The southwest corner. And we'd love to talk to you and stuff if you have any questions. Thank you, sir. Appreciate it.
Thank you.
Stuart, Honduras.
How many of you have participated in the mission trip? Wow, a good proportion of you. Good experience? If it didn't conflict with studying and other responsibilities, would you do it again? 100%. All right, excellent. How many of you have not? And would like to? Still hands up. Okay, well hopefully you will be able to at some point during your training here or immediately afterwards. Let's get going. Hopefully you had a chance to access the quiz and participate in it. Again, I'm looking for you to do it at least 3 times, well, max 3 times to get the extra credit. We have a very compressed schedule here. We don't have a lot of time to kind of do the quiz in class or to go over that material repeatedly in class. So I want you to do the quiz. It's a small measure, but do the quiz over and over so at least some of the material starts to sink in, okay? Some of you have figured out a solution for Jamovi on your laptops. Great. If you've not, IT group is still trying to figure out why it's not installing properly on your machines. So if it's not working for you today, sit next to someone who it is working for and work along with them. Anyone have serious Jamovi issues, or you're able to kind of get something going for today? Very good. Okay, so we have a few slides to get through right now to catch up with central tendency and dispersion. By the way, go back into Canvas, look at the modified syllabus, and it will have the CW sections that should apply to each week. Okay, so by the end of the course, if you're looking for the extra credit and not the point subtraction, make sure that I see that you've completed the CW sections. This is the Cheryl Willard statistical methods. Okay, so make sure I have a chance to see that before this course finishes. All right, so let's jump into the lecture for today. It's really important that we understand the application of central tendency and dispersion so that we figure out how these statistical procedures work. Right? So one of the things that we need to understand is that there's a difference between standard deviation and standard error. Standard deviation is a term that we use for the average amount of deviation in a sample. It's the square root of that. When we're only interested in a specific individual. Okay, so you guys as a sample, if I took one person out, the way to reference how far away that person is from the mean is to talk about standard deviation units. Okay, that's a way to standardize a score. But when we're talking about a sample, that is your mean compared to the average measurement for all dental hygiene students, your sample is now something that we're using as an error estimate. Okay, so instead of it being standard deviation, how far you are away from the mean, it's now called standard error. And now we see that standard error is a function of not only the standard deviation, but it's also a function of sample size. So tell me what happens to error in the estimate. That is, again, I don't really know what the average height is for all dental hygiene students, right? But I'm going to use you guys as an estimate. So you're not all dental hygiene students, but you're a sample. So I take you guys as a sample, I take all of your measurements, I take your average. Now the question is, how far away from the true measure is the average I collected for you? That's called standard error. What happens to standard error if my sample size decreases? Right, the standard error increases if this denominator decreases. So instead of using all of you as my sample, if I use only half, my sample size has gone down, which means whatever measurement I get as an average for that smaller group is now going to have a larger error in my estimate. Right? Okay, so that's something that we need to fix, and there's only one way to fix that. There's only one way to fix that, and that's with sample size. The other way to try to fix that is harder. Standard deviation can be decreased too, but that requires you to use a more precise measure. And we don't always have a more precise measure. Okay? So if we don't have access to a more precise measure, but we need to keep our error in the estimate down, increase your sample size. When you're reading a study, oftentimes you'll see a figure like this. What is this figure? What kind of figure is this? Is it a scatter diagram? Is it a box plot, bar graph, line chart? Right, it's a bar graph. So when you see a bar graph like this, oftentimes you'll see these error bars around it. And these error bars can either be standard deviation or standard error. Now, whoever wrote the article should tell you, and if you look at the caption down here that says this is a bar graph showing the mean, that is where this top part of the bar graph is, and standard error. Now, since you now know what standard error is in terms of its calculation, you have an idea of why the standard error looks like this as opposed to something much wider. What do you think would happen to these error bars if they had used standard deviation instead of standard error? Will these error bars be more narrow or wider if they use standard deviation?
More wider.
They would be wider, right, exactly. So remember, standard error is standard deviation divided by sample size. So if they're using standard error, it's because it's standard deviation divided by this. So it's always going to be smaller. Standard deviation, or standard error will always be smaller than standard deviation. And that's why sometimes when you're reading an article and you look at the figures, you'll see that they've used standard error instead of standard deviation because it's a lot more narrow than they use standard deviation. What we learned last week that standard deviation should go with the mean, not standard error. Okay? Same units for standard deviation and same units for mean. So when you see standard error, it's not that it's wrong, but be careful of the conclusion that you might tend to draw that, oh, there's a nice and tight spread for the error, when this is actually not the spread for the sample. The spread for the sample is a lot wider. Most people don't want to show that. This is a study I'm going to introduce you to later. The title here is Can't Always Get What You Want, the Influence of Choice on Nocebo and Placebo Responding. Do you know what a nocebo is? How about a placebo? Okay, what's a placebo effect?
It's when you believe that the treatment worked when it wasn't intended to work.
Okay, believing the treatment works when it wasn't intended to work. That's very good. So another way of saying that is when you're exposed to something that really doesn't work, it's an inert substance or an inert interaction, you shouldn't get an effect. But when you consistently get a positive effect, that's called a placebo. You get a positive effect. It's a real effect from an inert substance or an inert stimuli. Okay. A nocebo, what do you think? What would your guess be for a nocebo? What's a nocebo effect? It is the opposite of a placebo effect.
Or no treatment, nothing positive.
All right, so again, you're exposed to an inert substance or stimuli, but you get consistently a negative effect. That's a nocebo. And so in this study, they're looking at the effect of choice as a nocebo or placebo effect, meaning some of you really like to have choice. You want to be involved in making choices, especially for yourself. And so when you're given choice, even though the choice might not necessarily be it may not be a real effect, it leads to a placebo effect. Something beyond the treatment. Treatment has an effect, but the placebo effect is something beyond that, simply due to you being given a choice. The nocebo effect is, let's say you want choice, but you're not given the choice. It's decided for you. That's where you consistently get a negative effect beyond what the treatment would have done. Okay, so this study looks at the effect of choice on whether you get a nocebo or placebo effect for patients. Okay, so we're gonna play around with this study a little bit later in the course, but I wanted to introduce that to you now. Okay, so we understand that with standard deviation, we're taking an individual out of a sample, right? And then for standard error, we're taking a sample out of a population and trying to find out how far away is that sample from the population. And again, the population statistics, we don't know what they are. So this is all meant to make sure that we understand that our central tendencies typically go here in the numerator, serving as our signal, and in the denominators are variability measures, or measures of dispersion. And when we can take the difference between, let's say, two means, let's say we have the population mean from one group, and we're taking the population mean from another group and subtracting them, this difference between the means is our signal. And then the denominator is where we have our variability or our noise. So these two groups, they have standard deviations. If we pool them, that is just take the average of the standard deviation, this ratio is the same as this ratio, signal to noise. It's the difference between the means or the variability. Okay? This is a signal to noise ratio. And this whole thing is now called effect size. It's the size of the effect that you're looking for, that you're observing, the difference between these two groups. Right? Another way to think about effect size, like t-shirt sizes, you have large, medium, and small. Or tools, a large tool, medium-sized tool, small tool. These are also converted to standard deviation units. You'll notice since these two, the numerator and denominator, have the same units, these are converted to standard deviation units. Okay? So a small effect is where that ratio is about 0.2 or less. So between 0.2 and 0.6 would be considered to be a medium effect. And anything larger than this 0.6, 0.7, 0.8 would be considered to be a large effect. The idea here is large effects are easier to find than smaller effects. So anytime, again, you're looking for a difference between two groups, you have the central tendencies or the means. Those differences, when you adjust by standard deviation, is known as effect size. And those sizes allow you to determine whether something is easy to find or small to find. How many of you have had to ever tidy up a garage or a basement? Okay. How many of you have ever had to find something in a garage or a basement? Right. And when you're looking for this something, the size of that something matters. If it's fairly large, you're going to have an easier time to find it than if it's smaller, right? Now, if it's something large that you're looking for in the garage, do you need a lot of time to find it? No. Sometimes. And when do you need a lot of time to find something that's large? Well, if the garage is massive, right? But more likely if the garage is not that tidy, if it's fairly messy. And so here, what we're thinking about is power. We're trying to figure out how likely is it for me to find something in a garage that looks like this. This, when you see all this messiness, is known as the variability, that's scatter. That's your measure of dispersion. So if there's stuff all over the place, if things are really messy, it's harder to find what you're looking for. What we're looking for is there a difference between these two groups? Okay. So what we're going to say, in order to understand power, the first thing we need to understand is sample size. How much time will I need to find what I'm looking for? And that time is going to be increased if I'm dealing with this kind of situation as opposed to this situation. The effect size would be the size of the tool. So if I'm looking for a very big tool or a very big box, it's a lot easier to find a very big box in something that's messy, right? It's really easy to find it if it's tidy though, the garage. Okay, so these are the three factors that are related to power. And power is defined as the ability to find an effect that exists. Okay. So power is, it's there, right? You're told the tool is there. Power is the likelihood or the ability to find it, given that it's there. So let's say you make a first pass, let's say you spend 5 minutes and you don't find it. What are you going to do then? Typically, what would you do if you don't find it in the first 5 minutes?
Take a break.
Take a break? You need a bit more work ethic there.
Do it again. Try it again.
Try again? Okay, so you're going to spend more time. You're not really going to try to tidy up the garage first and then try to find the tool, unless you're really not finding it and you're saying, you know what, this place just needs to be tidied up. Let me just go ahead and tidy it up and then see if I can find it. So the idea here for us to understand is central tendency is going to contribute to our effect size in the sense that it tells us how big this tool is. And when we adjust by the experimental scatter, right, how much variability there is, now we have the likelihood of, are we really going to find this effect statistically or not? So these are the three factors I want you to keep in mind. How long you'll look, how big is the tool, and how messy is the garage. If you can keep this in mind, then you'll have a pretty good idea of what it takes to find an effect statistically when you're running these hypotheses. All right, so let me show you, not how to run the hypotheses, but let me show you what we need to understand a bit more about central tendency and dispersion with your Jamovi software. Okay? So let's go ahead and open that up. You'll also want to make sure that you've downloaded the lab for today, Lab 2. Bring that into Jamovi. Your file should look something like this. Okay. How are we doing so far? A couple more minutes? Okay. Yes.
So will our final be on a paper or, on Jamovi?
Good question. So for your midterm exam that's coming up in 2 weeks, the midterm exam requires you to do mostly Jamovi software. I know that there is ExamSoft. There'll be a couple questions, like the quiz questions with ExamSoft. But what you really need to do is you really need to turn in a Jamovi file that is very similar to what we're working on. For the final exam, there are even more questions for the ExamSoft. And again, there's another Jamovi database where you need to address questions with the data that's there.
So are they similar to the homework we got?
Yes, very, very similar. Very, very, very
Can we go
similar.
over those?
Yeah, we're doing that right now. We're doing that right now. Yes.
And will the midterm be done in our own time?
Right now, I'm trying to find out how much time we have for the exam soft. We have a full class period to do that, but I don't want us answering questions with exam soft the entire period. It does take a while for some people to work with the Jamovi, so I'm wondering to make the Jamovi part asynchronous, where you start a little early and then you turn it in by the midterm, 12 o'clock p.m., or having you do it here. But there's too much stress, I think, trying to do it here. So we'll see.
Do it on our own time?
We'll see. We'll see. Yeah. But the exam soft definitely, yeah, here. There were a couple other hands. No. Okay. All right. So let's look at our Jamovi database here. It should look very much like what you had last time. You've got a state variable. I'm gonna have to swing out here. You've got a state variable, a region variable. Now, in the one that you downloaded, you probably don't have the west, midwest, south, and the northeast in there. So go ahead and repopulate that. So relabel that variable. Do you remember how to do that?
Click region.
Yeah, double click on your region, okay? And then you should have a window that pops up that allows you to adjust or change the characteristics of your variable. So double click on region, that's one way to do it. Double click on the label there of region. And up here, you have the opportunity to go ahead and put in what a 1, 2, 3, and 4 are. So 1 is the west, 2 is the midwest, 3 is the south, 4 is northeast. All right? And if the variable name is not specific enough for you, go ahead and add a description there so that when you click on the variable, you remember, oh, this is the region of these are the regions of the US. What kind of variable is region? Nominal, ordinal, ratio, continuous, nominal. Very good. Nominal is a variable in which the levels differ by what only? They differ in name. They differ in name only. That's the only quality that's separates them. All right, so we've got a region variable. We've got a density of dentist variable. What is the density of dentists? Can you describe that variable?
10,000.
How many dentists per?
Region?
Yes,
How many
per region,
for
but
10,000 person?
per 10,000 person, per 10,000 US. Okay. For 10,000 people in the US. Next to that, we have the Medicaid variable. What is our Medicaid variable? So Medicaid providers, what is that variable?
The number.
How many dentists are accepting?
Right, so this is the proportion of dentists who are providing Medicaid, or a proportion of dentists who will accept Medicaid. Next variable, kids prev in 2016. So this is the proportion of kids receiving preventive dental care past year in 2016. So that's when that survey went out. The next one is Kids Prev 2007. Proportion of kids or percentage of kids receiving preventive dental care in the past year as reported in 2007. And right next to that, we have Kids Prev 2011. Proportion of kids receiving preventive dental care 2011, or at least reported in the past year for 2011. So we have 2007, 2011, 2016. And in addition, we have this other new variable called affordability rank. So this is data that I got from the Commonwealth Fund report for 2016, and it's telling us the rank of affordability of healthcare in that state. So if you get a very low number, like rank 1 or 2 or 3, that means you have very affordable healthcare. Scores of like 47, 48, 49, 50, very low rates. It's expensive, right? So not affordable healthcare. So I took that variable, which we're calling an ordinal variable or continuous variable, and right next to it we have another variable called affordability rate dichotomized 2016. So I took that variable and I made it into a nominal variable with 2 levels to make it easier for us to use. That is, for all the scores that were less than or equal to 25, we're going to call that affordable care. Those are the zeros.
So we have to type that in.
Yeah, well, if you want to know what the zeros are, yes, you have to type that in. So you don't have to, you have a choice. You have a choice. When you turn in a Jamovi data file, like you will for your midterm and final exam, I will be looking for that. And then the ones will be for where the affordability is greater than 25, and we're going to call that not affordable. So in 2019, well, it's been reported for 2019, for 2018, which state, sure guess, that has the least affordable health care? Which of our states has the least affordable health care in 2018?
Mississippi.
Mississippi? Not Mississippi.
Give us a region.
Give you a region?
Yeah.
You're right, it's in the south.
It's the district of,
Miami.
Not Miami.
Tennessee.
Sorry?
Tennessee.
Not Tennessee. Boy, I'm getting a real picture of which states you're
Louisiana.
hating on. Mississippi, Texas. It is Texas. Wait, okay, so yeah, why are you saying, oh, makes sense. Why Texas?
It's too big.
Texas is massive. It is huge. But why would Texas, with where most of our oil comes from, offshore, why would Texas have the least affordable health care?
Sample size increase.
Sample size changes.
Time.
Number of, let's look at the provider number.
Very good. So some are saying, well, let's look at the number of providers or density of providers and see if that might help explain it. One of the things that we're going to try to do by the end of this course is have some real hypotheses with real data that back up our ideas as to why is it that Texas has the least affordable health care in the U.S. And then why politically are they making certain decisions regarding census and other things that are happening and being discussed right now. So by the end of the course, hopefully we'll be able to participate in the discussion because of data that we've looked at. Okay? Not because of maybe biases that we've inherited, but we've looked at the data, we understand what's happening, we have some ideas as to why that might be. But let's take this variable, this affordability variable, and let's associate it with the proportion of kids who are receiving preventive dental care. Do you think that it's likely that kids who live in states where healthcare is not affordable, that they have higher or lower rates of receiving preventive dental care? Lower rates, maybe. Okay, so that's a hypothesis that we have. We're going to test that officially in 2 weeks when we start testing hypotheses with statistical tests. But right now, let's build the tables with the means and standard deviations, and let's look at the bar graphs and the histograms to see if we can find some differences. Okay, so the first thing we want to do is to characterize the entire U.S. Entire U.S. for the trend from 2007 to 2011 to 2016 for the proportion of kids who receive preventive dental care. We want to know what's going on. Okay, so in order to do that, go back to our Jamovi. You want to go to Analyses, Exploration, and Descriptives. Analyses, Exploration, and Descriptives. Okay, so help me out from there. What should go where if we want to determine whether there is a trend, or we want to characterize a trend from 2007, 2011, 2016, for a proportion of kids receiving preventive dental care in the entire U.S.? Okay, so we're going to take those 3 variables and then what?
variables.
Put them over in variables, so 2007, 2011, and 2016. Yes?
Yeah.
Is that it?
No, and you have to.
So we want the entire U.S. We don't want to stratify our data just yet. So that's it. So let's make sure that we have the stats that we want. So underneath where we have statistics, we want to make sure that we've got the statistics that we want. So we definitely want the mean and median. What else do we want?
Standard deviation.
Standard deviation, variance, skewness, kurtosis, and Shapiro-Wilk. So we'll get an idea of how symmetric the data set is. We want to know if this data is normally distributed or not, and whether it's got that one peak or multiple peaks.
So histogram.
Right, so it lets us know how homogeneous or heterogeneous it is. So we also want to ask for histograms with the density curves. Okay. So let's start at the top with our table. 2007, 2011, 2016. All right, so we're going to take a look at the mean measures for the proportion of kids receiving preventive dental care, and what do we find? It goes from 79.4% to 78.3% to 80.8%. What's going on there? Describe it in terms of the mean. Okay, so it starts at 79.4%. Yikes. Sorry about that. All right, starts at 79.4% for 2007. Is that meaningful to you? Is that higher or lower than what you would have expected for the proportion of kids receiving preventive dental care? I hear it's okay, that's all right?
You say over 50 and lower would be too low.
Okay, so I'm hearing here in the front that 50% and lower would be too low. I would agree, 50% is too low. But 79.4%, how do you feel? You're clinicians now. Are you happy with that, or would you rather see that number higher, or you would be okay with it even a little lower for the whole U.S.?
It's not ideal,
Okay, not ideal.
but it is what it is.
Okay, so more kids are receiving preventive dental care than not.
That's good.
Okay, so that's good. Okay, fairly low bar here. U.S., the leader of the free world in terms of healthcare and capitalism. All right, 79.4%. But then in 2011, drops to 78.3%. Is that a significant drop, or is that just random variation? Survey methodology error. What is that? Is that real, or is it random?
Maybe it's real, it was 2000.
Okay, so if it were real, what do you think this drop would be due to? Now, this is the entire U.S. Has anything happened from 2007 to 2011 that you think might realistically contribute to a drop in the proportion of kids receiving preventive dental
The
care?
economy that dropped in 2007.
Okay, so 2010, we had a fairly significant financial crisis, okay. Anything else? Right, recession, so financial issues, yes, which affected the nation and personal households.
Is it like budget cuts? Like
Uh,
healthcare cuts?
So the question is whether healthcare cuts would have
Like
contributed to that.
provided by their state, like no funding from the government?
Okay, so that's a very good observation. When we think about what happened at the federal level and what happened at the state level, yes, certain states, because of what was made available at the federal level, tried to figure out, well, how are we going to pay for that? So what happened around 2010 at a federal level in terms of healthcare?
Do they cut dental college?
No, not really, no. Not directly anyway. Affordable Care Act, right? 2010. So access to care supposedly increased around 2010, but we find there's a decrease in the proportion of kids receiving preventive dental care. May be related, may not be related. Maybe this is more of an artifact of the financial issues. We don't know. But when you start to see these kinds of numbers, when you look at the central tendency, we said, mu2 minus mu1. So mu2 might be 2007, New one might be 2011. When you look for that difference between these two populations or these two samples, we start to get an idea of, is this real or not? So we would have to adjust by the standard deviation, which is pretty small, 0.0352, 0.0405, to see if this amount of error is less than what we would get from the difference between these means. So in 2 weeks, we will actually test this to see if this is a statistically significant drop. But whether it's clinically meaningful or not, you guys have to answer. That's a judgment call. Some of you might say, no, it's not enough. Some of you might say, no, I need to see a 3 or 4 percentage point difference for me to say that that's meaningful. Okay? And that's fine. That's entirely up to you. All right, but what happens from 2011 to 2016? We go from 78.3% to now 80.8%. Again, is this just random fluctuation? Or do you think this is real movement?
It's a real movement. You have like a huge sample number, so it can't be like just error.
Okay, so the standard error is really small for a group like this because of the sample size that goes into these measurements. This is a very large study, so the error is very small. We're also dealing with an entire population, right? So we're getting closer to dealing with the entire population. We're not dealing with a sample anymore, we're dealing with the actual measurements for that population. So they're not statistics anymore, they're parameters. They get closer to being parameters. But the 79.4 dropping to 78.3 and then now rising to a level beyond which it was at 2007 means maybe by this time in 2016, Affordable Care Act is starting to kick in, people are aware of it, people are enrolling, signing up, people are thinking more about health care, and maybe now they're more likely to participate in activities like prevention methods for their kids in terms of oral health. Maybe, it's just a hypothesis, but we need to, as policy analysts and as clinicians, you have to describe what is happening here and be able to attribute it to something. Okay, so recognize that it's dipping and then rising, maybe to the same levels or beyond, and then figure out why is that happening. Okay. One of the other things that we'll look at too is if we look at the Shapiro-Wilk test, the Shapiro-Wilk test is a test of a hypothesis. That p-value is a conditional probability. It's saying the probability of something given something else. So this is saying, what's the likelihood that you have a normally distributed variable given that you sampled from a normal distribution? So the p-value here is 0.246, and it's saying, don't get rid of that null hypothesis. You probably sampled from a normally distributed sample. So when this value is greater than 0.05, it means your data is normally distributed. Okay? If we look for 2011, we say that it's 0.06. It's a lot closer to that threshold of 0.05, where we might have to reject the idea that it's normally distributed. And then here in 2016, what is the value? It's less than 0.05. So what do we do to this assumption of normal distribution? We get rid of that. So let's look at the curves and see if that's actually true. So here in 2007, we have a look at the distribution. Kind of looks like it has one peak, right? I mean, it's not entirely symmetric around its mean, but we can see that here at 0.246, it's saying it's somewhat normal. We can work with it. It appears like it's coming from a normally distributed, or that it has a normal distribution in 2007. Same variable in 2011, what does it look like? Same variable 2011, what does it look like?
Higher peak.
Okay, still looks like there's one peak, but you're starting to get the hint of something out here. Does it look like there's another distribution kind of peaking or popping up around here? Okay, so it's not strong, but it looks like it's normally distributed. The statistic tells us what? Statistic tells us 2007 is 246, 2011 is 0.06, so just beyond, but it looks like maybe it's not normally distributed. There's a bit of a outlying distribution up here. What happens in 2016? Well, not quite. I don't think that had an effect on the proportion of kids receiving preventive dental care, but that would be awesome if you had data suggesting that there was an association. You should write that up, quit this, go to get your poli-sci degree, go to the White House and start working there, because that would be some insight. What do you see here in 2016? What happened?
Skewed to the right.
Okay, there appears to be maybe a skew to the right, or depends. If you want to know where the skew is, what statistics should you look at? Yeah, look at skewness. So here the skew is not to the right, is it? Where is the skew? To the left. This is a lot more negatively skewed than this guy is. And when you look at the distribution, what do you see? Look at the distribution, because the means don't look like they're changing all that much, right? You can't always tell everything from looking at the central tendency, which is why you also need to look at the histogram and characterize those. It looks like we have two full-on distributions. This is known as a bimodal distribution. It looks like there are two modes here. It looks like here's one distribution, and it has a mode here, peak. Remember, the mode is just the score that appears most frequently in that sample, right? So here's one distribution with its mode, and it appears like this is another distribution with its mode here. So this looks like a bimodal distribution. In other words, proportion of kids who received preventive dental care in 2007 looks like one population, the whole US. Proportion of kids who received preventive dental care in 2011, again, looks like one population with maybe a little hint of something happening. By 2016, proportion of kids who are receiving preventive dental care is a bimodal distribution. It looks like there are two populations in the US now, not just one. So there's this group, and then there's this group. Okay? So although you look at the means, if you were only given the means, you'd say, oh, it doesn't look like there's not much happening. But when you look at the distribution, it looks like there's a lot that's happening in terms of proportion of kids receiving preventive dental care. U.S. is one country with proportion of kids receiving preventive dental care in 2007, 2011. By 2016, it's two countries, two different populations. Okay. You're not loud. Wow. Ooh. Question?
So like when we're describing the graph.
Yes.
What if, I don't know like the correct vocab to do, but let's say in 2007 this shape is not entirely symmetric.
Yeah.
What should I use? The shape
That's fine. This is a really good question. So the idea here is, how accurate do I need to be in terminology right now? This first half of the course, I'm putting zero emphasis on terminology. Last half of the course, this is where we go step by step in testing hypotheses, and we go stepwise order and we use specific words. But right now, I just want to get you comfortable looking at it and in your own words describing what you see. I see that the means aren't changing that much, or I see that the shapes aren't the same, or it looks like here there are two distributions instead of just one. Right now, terminology, I'm not really big on. In the last half of the course, that's where I start asking you to use certain words more repeatedly. Okay? That's a fantastic question. So right now, I just want you to get comfortable. I looked at it, and yes, I saw the difference, and here's how I'm going to describe the difference. Do you guys see anything else in the comparison between 2007, 11, and 16 with these histograms or with the statistics that you think are meaningful to you? Everyone does. Sometimes it's like art. Everyone doesn't always see the same thing. The question is whether it's real or not. You go see a painting, you see something, I see something. We have no idea what the artist was thinking or what they want you to think when you interpret it. But the question is, you see what you see, and I see what I see. I might see what you see, when you explain it to me. You might see what I see if I explain it to you. So what else do you see when you compare 2007, 11, and 16?
It's not about the comparison, but a question.
Yes?
If you look at the 2016,
2016?
the bars are like all connected except the first one.
Okay, so you mean this one?
Yes.
Okay, so these are histogram. histograms. And with these histograms, it's going to try to treat each of these measurements from these states as discrete. So there might be separations. But the way we get around that is by using this cumulative density function. So we get this smooth curve. But what I want you to do is to look at or appreciate the smooth curve. The discreteness or the separation from these is only meaningful when we get something like this, where it's trying to indicate that there's a difference between these two distributions or these two populations. Sometimes when we see that separation, it might be an indication that there's an outlier too, like in 2007, I think as you were pointing out. This gap here is letting us know, wait, maybe this state is an outlier from the rest of the nation. Yes. Question?
For the 2016 graph.
2016 histogram, yes?
Yes. You called that bimodal.
Yes.
Would calling it heterogeneous?
Yes. Yeah. So heterogeneity would be another term that we would use here, but someone might ask you more specifics. So for example, you said, when I look at 2016, it definitely looks like a heterogeneous sample or a heterogeneous population. And someone might say, well, how so? You might say, well, because I think it's bimodal. It looks like there are two distributions there. Heterogeneous might also be three distributions, which we'll see later, or maybe four or more. So the heterogeneity might be, yes, there's more than one here, but being more specific, we'd be calling it bimodal. It looks like there's two modes here. Yes?
I briefly looked at the book, and I noticed that some things were different. Does the book ever go over this?
Which book? Cheryl Willard or the first one,
The
Jamovi's
workbook.
book? The workbook won't go into this kind of detail. No.
So what would the workbook help us with for this?
The workbook helps you to understand
The terminology?
some of the terminology, but calculations of means, calculations of standard deviations. And once we start getting to the standard score, one of the things that we have to do is, for example, take a look here. The workbook exercise, when it teaches you about probability and how that translates into a standard normal curve, you'll understand why we can't do that with this distribution as well as this distribution. The reason is, when we think about probability, probability is in relation to relative frequency. So if I create a map that looks like this, and I try to superimpose this map on top of this map, there are problems. Because this map says in the middle of this map, there's a very low frequency. But this map says, no, in the middle of this map, it should be a very high frequency. So what the book does, the Cheryl Willard book does, it teaches you about probability, frequency, and how things need to look like this in order for the stats to work. But it won't teach you that if it looks like this, your estimates will be off, significantly off. So what I'm using with the Jamovi software is I'm showing you, this is why you can't always just trust the statistics as they come out. You have to look at these figures and say, wait a second, the reason why I'm not going to take the p-value from here, and when I apply it here, trust it so much, is because I know this is a bimodal distribution. Cheryl Willard won't do that with you, but she will teach you how to calculate all this to come up with the standard normal curve, which we need to do for statistical testing. So there's no one perfect book, unfortunately, and I don't have time to write one. So unless there's some volunteers. Yes?
Is there a correlation between skewedness and distribution?
Yes. So when we talk about a skewness and distribution, if we look at this distribution here in the middle, the skewness says, well, how symmetric is this data? If it's not symmetric, then that means there's a skew somewhere. The question is it skewed to the left, a negative skew, or skewed to the right? So the skewness variable, if it's non-zero, the sign will tell you where is the pool. Okay? When you look at the distribution, you can get the same thing too. So this one we know is negatively skewed because here's the higher peak, right? And then I see another distribution out here. So this mean is going to get dragged down here because of the weight of this guy. So when I look at the skewness says negative 0.6 whatever. And if I look at this distribution, I also know that, oh yeah, there's a skew because this group is going to pull this mean down towards it. So I know there would be a negative skew here. Right? So one way you can do it numerically, quantitatively, with a statistic. The other way is to just use it qualitatively. Look at the distribution and just write about it, characterize it. Good questions, good observations. Any others? Is there anyone for whom you're brave enough and courageous enough to answer, this is too slow for you? Anyone this is We should go faster. No? No one wants to be that person that raises their hand. Anyone, is there anything that we spoke about that we need to just double back on? Or circle back to? Yes?
Can we meet with you to maybe discuss it and go over like the software and make sure?
Absolutely, absolutely, absolutely. I don't have set office hours, but I do have time set aside. So if you guys want to come and meet with me, I'm more than happy to. I have a lab set up over there. You all can sit at different stations and run at the same time. Okay. Question?
Is there any way that you can provide us with like a sample of how you want it written and so forth?
Yes, after the midterm. So in this first part of the course, I just want you to get comfortable completing the assignment. I don't want you to get too much in a formula. The biggest problem I have in teaching statistics is, especially in the clinical sciences, is the clinicians come into it thinking it's A, then B, then C, then D, then E. And it really isn't. So the first thing I need for us to get comfortable with is just jump in there and just write what you see. The questions are open-ended. Tell me what you see. It's all valid. After the midterm, then I give you the, okay, when we test a hypothesis, you start here, and this is how you write it. And then when you say your assumptions, these are the 4 assumptions, and here's how you test every single assumption. It's either yes or no. And by the time we get to the end of that stepwise process, whereas did we reject or fail to reject the null hypothesis, and then what do we state? All of that is cookbook method. But in this first part, I just need you to get comfortable. I open up the software, there's the data, I start looking at the tables, I look at the figures, do I see differences or not? Okay, so the first part is very loose, just to get you comfortable. Then after you're comfortable, then I start to kind of form you into, okay, now it's A, then B, then C, then D, A, then B, then C, then D. But if we do this too early, you kind of lose the concept of what we're supposed to be doing. Question?
You were talking about the descriptives.
Yes.
The Shapiro-Wilk.
Yes.
You were talking about it in a way where it's meaning something to you.
Okay.
As far as the years go, you would look at the values.
Yeah.
And you would say, oh, that's less than or greater than, I think you said like 0.5.
0.05.
0.05. Where did you get that 0.05 and what does that mean?
Right, it won't mean much to you right now. So again, you'll notice that I'm not holding you to that in any of the exercises, and on the midterm it won't be there, but I'm getting you used to hearing it. So the 0.05 is a threshold. It's a special threshold. And this threshold is any probability value, this p-value that's less than 0.05 says you're going to have to reject your null hypothesis, or this assumption that you hold about the data. And for this test, this is a specific test, this test is testing for normality of the data. So it's got to have this bell-shaped curve and be symmetric about its mean. So if this value is less than 0.05, it means, yeah, this data is bell-shaped and it's got a big mean here where the mode is, and the median is also probably there, and it's fairly symmetric. When it's less than 0.05, if it's greater than 0.05, it's saying, I'm sorry, when it's greater than 0.05, it's normally distributed. Less than 0.05 says it's going to look something like that, where it's not normally distributed. You might say, oh, it is up here. Yes, but the whole thing has to be. So anything that does not look like one normal distribution is going to have a p-value less than 0.05. And that's what we're looking for. Now, since these are probabilities, some of you use probabilities like in matching. I don't know if any of you have participated in anything where you're looking for a probability match. Higher probability matches have higher probability scores. So if we look here, this p of 0.246, it's higher than 0.033, which means this distribution is more normally distributed than this one, because the p-value is higher. So the closer to 1.0 for this test, the more normally distributed your data is. Yes?
So in other words, normal distribution is homogeneous.
Yes, the normal distribution I'm treating as a homogeneous distribution. There is some natural variability, but it's saying you sampled from one population. That sampling from one population I'm using as a proxy for homogeneous. Now when we say that it's heterogeneous, that means, wait, you sampled from more than one population. You probably sampled from maybe 2 populations or 3, like we did in 2016. These are really good questions, really good questions. How are we doing? Are we good so far? Okay, so now what we need to do is to take what we've done for the entire US and stratify it by region. Because we want to find out if what we're seeing in the US is true for every single region in the US. So how do we stratify our data?
Split it by region?
Thank you. So explore, descriptive. Unfortunately, I have to go back in. See if you get there before me. You did? All right. Tell me what you see in 2007 for comparing the proportion of kids who receive preventive dental care among these regions. So one of the things you might do is start and identify, well, which region has the lowest proportion or lowest percentage of kids receiving preventive dental care? So is it the West, Midwest, South, or Northeast?
The West?
Sorry?
The West?
Okay, so the South at 77.7%. Okay, followed by who? The West at 78.4, then followed by Midwest at 79.9, and the Northeast at 83.3%. Okay? Then the next thing you might want to do is say, okay, I'm going to go back, I'm going to start at the lowest, and I'm just going to go over time and kind of see what happens to their value, their proportion of kids receiving preventive dental care. So here, the South is at 77.7%, and then in 2011, it dips slightly to 77.1%, and then it increases to 79.9%. That's higher than it was in 2007. So again, we're wondering if, for example, if our hypothesis is that the Affordable Care Act, in part, has a part, is in relation to the kids receiving preventive dental care, we're wondering if the South experienced a bit of a bump due to that. Maybe some regions experienced a bump, maybe some regions didn't, but maybe the South did. Let's look at the West. They started at 78.4%, then they dropped to 77.4%. Then what happens? Whew. Yeah, they swoosh up to 81.5%. Okay, so maybe the effects in the West is even stronger than it was in the Midwest. Okay, followed by, West followed by the South. And then the Midwest is 79.9% to 77.9%, so it drops, and then it only comes back up to 79%. So it doesn't even get back to the level it was at when it started, or when we started measuring, which is a totally different effect than what we see in the West and in the South. If we look at the Northeast, they're the leaders, 83.3, 82.3, 83.8. They don't seem to be moving around that much. Okay, so Northeast doesn't change that much. South didn't really change that much, but then increased a little bit by 2016. Midwest dropped and then was trying to make a comeback. Then the West dropped, but then they really shot up. Okay? So the trend over time for the different regions is different, not the same. So if we want to talk about what happens in the US from 2007 to 2011 to 2016, that's one characterization. But if we look at by region, it's an entirely different trend for each region. So we have to separate. We have to stratify our results. So we really have an understanding of what's happening in the different parts of the US. So to further that characterization, we want to take a look at the histograms. So why don't we do that? 2007, what do we see? What do we see? Right, well, there looks like heterogeneity there, 2007. So in the West, it looks like there might be more than one population or sample. So we have a lot of the states are clustered here, but then we have one or two states down here, and then we have another state that's an outlier up here. Okay. In the Midwest, they're more clustered together. We have a nice middle here. These could be other distributions, but this might get treated as just one normal distribution. The South looks like, again, they have a distribution here, but then an outlier down there. And the Northeast
evaluate.
Yeah, it looks like we might, at least in 2007, it looks like we're getting the hint of maybe 2 different distributions there. Bimodal possibly, so 1 here, 1 there. If we go up and we look at our Shapiro-Wilk test for 2007, what do we see? We're at 0.108 for the West. What does that mean? Is it normally distributed? If it's greater than 0.05, yes, it's normally distributed. So yeah, or it's normally distributed. What about the Midwest? 0.725, and that's a lot bigger than the 0.1. So the Midwest is considered to be a lot more homogeneous than the West at 0.108. What about the South at 0.06? Ooh, it's getting close. I mean, it is normally distributed, but it's getting really close to that level where we say, ooh, it's not normally distributed. And then for the, and this is probably why, if you look at the Northeast, what do we find in the Northeast? 0.848. I'm saying it really is normally distributed. Although, when we look at it, it looks like there is this bifurcation here that looks like it might be bimodal. Okay? And you say exactly what you see. When I look at the test tells me it's normally distributed. When I look at the histogram tells me maybe normally distributed, but I definitely see something that looks like 2 different distributions. Yes?
For the Shapiro-Wilk test,
Yes.
is 0.05 normal or 0.5?
0.05. 0.05.
Okay.
Right. 0.05. The 0.05 is a probability level. And this probability is the probability of making an error. Okay, so when we look at this value, we're saying, let's assume the data is normally distributed. What's the likelihood that you would make an error if you assume that based on the data that you have? So this is saying that we're going to keep this low, or it's higher, low, higher. And so one of the ways that you want to think about it is when you go to, you're not going to go to court, hopefully, but if someone is accused of something and they go to court, criminal court that is, and you're innocent, you want to keep the likelihood of you being found guilty really low. It's going to happen. It does happen to people. They're innocent, but they're found to be guilty. But we want to keep that low. In this country, 5% is that magical level that we would like to keep. So the likelihood of an innocent person being found guilty, it's not improbable. It is possible. We want to keep that low, so 5% or less. A beta error, it's a different kind of decision error, and that's the likelihood of, let's say, someone who is guilty being found innocent. We are willing to tolerate that at a 20% level. So beta is at 20%, alpha is at 5%. So here, we're wanting to determine what's the probability of us making some of those errors. So when we run the test, we say we want the alpha error to be really low, so 0.05, okay? And then when we run the test, we're saying now, what's the likelihood that what we're seeing is similar to the null hypothesis? This is high, this is high, this is low, and this is sort of low. Yes?
So I just want to get this clear. So the Shapiro-Wilk test tells you if it's normally or abnormally distributed and the probability of it being abnormal.
So normal versus not normal. And this is the probability. So if this is really low, this means you have to reject your null hypothesis. So the likelihood that you would see what you're seeing if the null hypothesis were true is really low. I know it's backwards thinking, but it's meant to protect against a specific bias, and that's called the confirmation bias. We all do it. We all look for information that confirms what we already believe. But in science, you can't do that. It's a big no-no. So you have to test the opposite of what you're looking for, which is called the complement of what you're looking for. When you have evidence against it, you can reject it. The only thing you're left with is what you actually were looking for. Yes?
So you're saying, if I'm supposed to write what I described, I would say the Shapiro-Wilk data shows that the regions, except for the South maybe, should look normally distributed.
Yeah.
But according to the charts,
The actual
they're
histogram.
not.
Yeah.
So there
That's
is
fine.
room for error.
Yeah, absolutely. This is statistics. There's room for error. So when we're saying, what specifically should I say, I try to avoid telling or dictating for students specifically what you should say. Just tell me what you see. And that's all we're supposed to do from a scientific standpoint. If you can assign the probability to it, fantastic. What about 2011? What do we see? How homogeneous or heterogeneous are those samples? West, Midwest, Northeast, South? Yeah, so for the West, it looks like well, we can start first with Shapiro-Wilk. Shapiro-Wilk says normally distributed for the West, normally distributed for the Midwest, maybe for the South, and normally distributed for the Northeast. And if you look at the distributions, you say, okay, maybe normally distributed, but it definitely looks like there's another peak down here. And here for the Midwest, I definitely get that. It's clunky, but again, look at the cumulative distribution function, the smooth curve. And then for the South, again, there's that outlier still. And then for the Northeast, what used to look like two distributions is now starting to look like one, just a little funky. And then for 2016, what do we see? So we can start first with Shapiro-Wilk. Shapiro-Wilk says, in the West, although in 2011 it looked like it was normally distributed, in 2016 it looks like maybe it's not so homogeneous anymore. Still, it's greater than 0.05, so you're going to assume, yeah, it's normally distributed. But when you look at it and you describe the histograms, it doesn't really look like it's normally distributed, or at least one sample, one population, maybe more than one. And then for the Midwest, normally distributed. For the South, not normally distributed. And then for the Northeast, yes, normally distributed. So when you look at the figures, for the West, no, this looks like this is heterogeneous. There's one sample here and another sample here. For the Midwest, it's saying it's normally distributed, but when we look at it, it looks like, there's an outlier or sample here, one here, but even here, it looks like there are two modes there. And then for the South, definitely not normally distributed. Right? And look at the skew here. So there's one group of 7 states here, and another group of 7 states here. And then for the Northeast, again, one tight group here, northeastern states, another tight group of northeastern states there. So there are times when from a probability standpoint, the statistic tells you something that our eyeballs are not necessarily telling us. But you want to report both, even if they seem to disagree. All right. So that's proportion of kids receiving preventive dental care from 2007, 2011, 2016 for the entire U.S. and then split out by region. Our real task here, though, was to find out what proportion of our U.S. Let me see if I can bring it up for us. Proportion of our U.S. has affordable health care and does not have affordable health care. So let's go back to our data, exploration descriptives. We're going to take our affordability rank, the dichotomized variable, put that in the split by. Okay? And then now in the variables, go back and put our kids prep. So now what you should be able to do is you should be able to determine what effect affordable health care has on the proportion of kids receiving preventive dental care. Does affordability in healthcare appear to have some effect on the proportion of kids receiving preventive dental care? So if you start in 2007, what you want to see is, do you get different central tendencies? Do you get different dispersions between those two groups? The states that have affordable health care, the states that don't have affordable health care. This is for the entire US, so not splitting by region yet. What do you see? I'm going to start getting rows involved. I haven't mastered names yet. I'm going to start getting rows involved. So row number 1, first row. What do you see for 2007? 2007, you can look at the mean or the standard deviation. Okay? Mean or standard deviation. Do you see any difference in the proportion of kids receiving preventive dental care when you split by whether these states have affordable care What do you see? First of all, do you guys have Jamovi? Is it?
Yeah.
Sweet. Okay. Were you guys able to build this table?
Yeah.
Excellent, excellent. You're doing well so far. All right, so in this column here, 2007. All we have to do is start first. Okay, here's affordable care, not affordable care. Which of these is higher?
Great, affordable.
Right. So we're saying I see a higher proportion of kids who are receiving preventive dental care, and that's at like 81%, in the states who have affordable health care than the states who do not, where they're at 77.7%. We don't know if this difference is real or random, but we just take what we see. It's higher. Is that what you would have expected?
Yeah.
Yeah, that's an intuitive hypothesis. I expect to see, in states where there's affordable care, I expect to see the families or kids participating in these healthcare activities more frequently. And that's what we see. Fantastic. What about in the dispersion? Do you see any difference in the standard deviation between these? So we're
It's
at
greater.
0.03 and 0.03, let's just round. Very similar? Very, very similar. Okay, so we don't think that affordable healthcare is doing anything to at least the dispersion of these measurements. Okay, so they're about the same. So now we can just focus on the means to see if these are different. When you have two people who have the same last name, the only way that you know that they're different people is if they have different first names, right? Because they have the same last name. The same thing with these distributions. If we think statistically they have the same standard deviation, then we can look at the central tendency, their first name, to see if they really are different distributions or different people. Okay, so 81 and 77.7, a 3 to 4 point difference. That might be real. That might be meaningful. Okay, really good job. First row. Second row, 2011. What do we see? What do you guys see? 2011. Sorry? It drops from, compared to 2007? Okay, so are you looking at the affordable or not affordable?
Both.
Okay, so both. So if we look at the affordable group, they drop from 81% down to 79.9%. If you round that maybe to 80%. So slight drop, maybe random variation. But when you compare that to not affordable, what happens to the not affordable?
That drops.
That one dropped too. So we see a drop in both of those states. So whatever is contributing to the drop might be a real effect since it's happening with each of these stratifications. What about the difference between these guys? Is it around the same magnitude as the difference in 2007?
Yeah.
Yeah, it's about the same magnitude. So whatever that difference is, it's holding steady from 2007 to 2011. Okay. Keep in mind that the methodology for the survey is go out to the entire nation. I apologize, I will adjust this for next week, or at least when we meet again. Whatever the survey methodology requires that they go out to the nation and they get people to complete the survey, whether through mail-in or through call-in. Okay? And it's different people each time. It's not the same family. It's not the same group each time. But it's a large enough sample to give a very good representation of those areas. So the fact that we still see these same changes over time, even though different people are responding, suggests that maybe the survey methodology is accurate and that these differences might be real. Okay? What about standard deviation? What do you see there? Any big differences between the standard deviations between these two groups in 2011? Row 2. Not really?
0.02.
Yeah, maybe not really. Maybe not really. So 0.038, 0.036, I think that's too small to be meaningful in terms of differences in standard deviation. But it did increase slightly from 2007. So a little more uncertainty from 2007 to 2009. Okay. Again, everything we're saying is not what you have to provide in your homework assignment. You don't have to do all of that. Okay? I'm not looking for all of that, but some of it, yes. Okay. All right, 2016, row 3. What do you see? Nice and loud. Sorry? An increase. So you go from 79.9% up to 82%. Okay, so the proportion of kids receiving preventive dental care in states with affordable care increases. Okay, what about in the states who don't have affordable health care? Yeah, it increases by another 3% too. So although the care is not affordable, we're still seeing a bump. So whatever is responsible for this decrease from 2007 to 2011 might be responsible for the increase from 2011 to 2016. Again, this 2011 measure, for now, I'm treating as a Affordable Care Act proxy. This is right about the time when the Affordable Care Act went into being, right? It takes some time for people to get used to that and for the markets to get used to that. So this is a nice measure that suggests 4 or 5 years later, this is where we're at. I think this might be an artifact to the Affordable Care Act, but we're not sure. It's one hypothesis, but we now have the data to kind of test it. And one way to test that is how consistent do we see these measurements in these different kinds of stratifications. All right, row 3, standard deviation. What do you see there? Okay, so there's a decrease in the standard deviation. So it goes from 0.036 down to 0.031, 0.038 down to 0.037. Okay, but there's a bigger drop in this group, in the affordable group, than in the not affordable group. But maybe negligible in terms of impacting our conclusion about how homogeneous these groups are. Okay, good. So we've stratified our results by affordable care, and we think affordable care, or at least that stratification, accounts for some of the differences that we see, because clearly these measurements are different. Okay. Really good, really good. All right, so next row, we're going to move down to our figures. And I want us to change the figures now. I no longer want to look at the histograms, okay, with the density plots. I now want to look at box plots. Okay. Much better, much better. Tell me what you see with these box plot figures when we compare the groups or the states who have affordable health care versus the states that do not have affordable health care. This is row 4. What do you see? What's similar, what's not similar? Or shape? Or the presence of outliers? Or the absence of outliers? Or where the bubbles tend to be, or how wide the bubbles are. And these bubbles just relate to density. That is, more states are there. Or the shape of the violin. Sometimes the shape of the violin, tends to skew to one direction. Yes?
Are you just asking us in regards to the first one, or just
Sorry,
all of them?
thank you. 2007, yes.
2007, okay. There is kind of a bottleneck effect on the non-affordable population.
Okay.
There's also just a lot more general dispersion.
Okay. Very good, very good. On the not affordable.
Yes.
Very good, excellent. Anyone else from row 4? You're one of the biggest rows. I think these middle 3 rows, you have quite a few. Anyone else from row 4? Since you described the not affordable so well, how about describing the affordable states who have affordable care? Tell me what's happening with their box plot with the proportion of kids receiving preventive dental care. I realize we're using a stratification from 2016 and we're applying it to 2007 data. I think that's okay for right now. Yes?
Are we in the 2011 one or
2007.
Oh.
If you want to go to 2011, let's go to 2011, because we're not done yet. Go to 2011. What do you see?
2011, there's more people by the mean, or towards the 26%.
Towards the middle. Yeah, you're right. So here in 2007, you see that we have more states that push out this whisker here and here. But in 2011, it's compressed. We have these states are now closer to where this middle 50% is. That's a good observation. Very good observation. Anyone else? Oh, yes.
Within the bullseye thing that we learned, and it was like the precise and accurate
Right.
and biased and non-biased, so would the one on the right, the non-affordable on the 2011, be a unbiased? I don't know, can you describe those words with that? Is that
I will attempt to. So when we actually know what the real measurement is, which we don't, when we know what the real measurement is, then it's easier to figure out how biased my measure is or is not. And here, because we don't really know. So I can tell you what the spread, what the dispersion is, but in terms of the bias, don't know. I know what the real measure is for the US, and so I could take a, what was the measure for proportion of kids receiving preventive dental care in 2011? We were at that little dip, 78.3 or something like that. Okay, so what I would do is I would take 78.3 and then put a nice bold red, I'm sorry, it's part like here. I put a nice bold red line there. And that bold red line would be your target. That's what we measure for the entire US. And now you can see all the dispersion around the bold US average in 2011. That's the best, that would be my best attempt at trying to create something like that on that figure. Question or comment?
I'm not really reading the box. How do I look at the box? Like, I want to know, but then I'm not really understanding the box plot.
Yeah, so these are called box plots. And the way to look at these box plots is right here at the end of this line, this whole line is called a whisker. Okay? And any dot that you see out in these whiskers, these observations are called, well, outside of here would be called outliers. Okay? Anything outside of the whisker would be an outlier. Anything from here, the bottom of this whisker, to the top of this whisker, is within 25% of the distribution. Okay? 25% of the distribution. And then from the bottom of this box to where the bold line is another 25% of the distribution. Then from this bold line to the top of the box is another 25% of the distribution. And then from the top of this box to the top of this whisker, the last 25% of the distribution. So this box plot splits your distribution up into 4 equal parts of 25% of the distribution. This box is special because it colors and tells us the middle 50% of the distribution, which gives us a really nice idea of where the middle of the distribution is, which is where our central tendencies should be. So the question you might have is, how wide or narrow is the middle 50% of the distribution? So here we can see this one is a bit wider for the affordable care than for the non-affordable care in 2007. You might also want to look at the proportion of, take this bold line is called the median. Is this median right in the middle of the box? Or is it skewed to one of the ends of the box? If it's skewed to one of the ends of the boxes, it's telling you whether there's a skew in the distribution too. Okay, because it splits your distribution up into half. So if this is the middle 50% and the median is right here in the half, great, you have a symmetric distribution. If it's not, like over here, then you have a skew in the distribution. When you ask for that violin distribution or density curve, the bubble tells you where the density or more of these states are clustering. So here, around this median is where we see the clusters. So it's here at the top. Here it's towards the bottom. Here it's kind of towards the middle, but there's a skew. Yes?
So you would want like a longer box, is like to represent the 50%? Or does that really
Not
matter?
necessarily. So for example, if you're clinicians, you have the option to choose between treatment A and treatment B for your patient. Treatment A has a much wider distribution in response than treatment B, a much more narrow distribution. So in that context, would you prefer treatment A or treatment B for your patient? They both have the same outcome, same mean response, but treatment A has a wide distribution, but its mean is the same as treatment B, but a very narrow distribution. Which would you prefer and why? B. Yes, I would prefer B as well, but why would you prefer B?
Because it was like, since the distribution is more narrow,
Yes.
that's, even though it has the same mean, it's more likely that the treatment will work.
No, it's not more likely that the treatment will work. I mean, you could try to interpret that way to the patient. But what's happening is, you're more likely to predict where that patient will be when they get back. So on average, because no one's really there at the average, and that's why I don't really like averages. But when you look at that distribution, you can say, ooh, because the dispersion is so narrow, we have a really good chance of predicting where you'll be at when you come back. So that's why you would prefer the treatment with a more narrow distribution, because it makes it easier to predict where you will be in that distribution, closer to that middle. Fantastic. All right, next row. Next row, 2016. What do you guys see? Oh, very skewed. Which one, or both?
They're both skewed, but it seems like the box is kind of the one on the left for affordable.
Yes.
It's more skewed to the others.
Okay, so we see a greater density here, then we also see like this cluster down here.
And
Very
then
good.
it's kind of the opposite for non-affordable.
And then it's flipped on the other side. So here, there's this cluster up here, which is dragging the median and the mean up there, or dragging the median up there, but then we have this nice cluster down here, which is also pushing out this whisker too. And so its mean is going to fall down here. That's why we kind of see this shape down here with the clusters up here. Very nice. Well done. All right, so that's with 2007, 11, and 16. Last thing we need to do is to stratify by region. What happens when we look at affordable care and non-affordable care within each region? Question note.
For the 2011,
Yes.
how come for the not affordable one, how
Right.
come the whisker doesn't go all the way down to the bottom?
These are outliers. This whisker doesn't go all, yeah, so this whisker will stop. Okay, this is a really good question. Look at this middle portion. That middle portion, the length of that is called the interquartile range. If you have observations that are beyond 1.5 times the interquartile range, that's the definition of an outlier. So this whisker will stop at the minimum score, and then these guys, since they are more than 1.5 times this range, they're going to be tabbed as outliers. So this whisker will stop here to let you know these guys are outliers. Really good question. Okay. Let's stratify our results by region so we can look at what happens in each region with affordable care and not affordable care. So keep affordability there. Take your region. Let's see if we get it right. I want to see region, and then within each region, affordability of the care. So right now, perfect. That is perfect. And I'm just going to start with the figures. I'm not going to look at the stats, just look at the figures. Because we want to, the figures make it really easy for us to really quickly find out where do I see differences. Differences that are meaningful to me. Next row. Is that row 6? Yep. Do we see any meaningful differences to you between the proportion of kids receiving preventive dental care between the states that have affordable care versus the states that don't have affordable care within each region? So does anything pop out to you? How are we doing on time? Okay, great. Where do we see differences? Differences that might be meaningful to you? South? What's happening in the South?
I don't know why they're both on the same one.
Here's South. It looks like they have similar medians, but something popped out to you. What popped out to you? Row 6. We're giving row 6 a little bit of help here. Are you guys row 6? I can count. I just don't want to amaze you. We're going to just put all of you. Those last 2 rows, we're going to put you in the same group. Last 2 rows, you're in the same group. But, I'm sorry, first name?
Sandra.
What are you seeing here that's meaningful to you?
It's more affordability compared to not affordable. Like,
Okay.
how spread it is,
Okay?
and they're
Right,
both
so-
of the same shape.
Yeah, the middle 50%, the interquartile range is a lot wider than the affordable care group than it is in the affordable care group. And part of that is going to be due to sample size. So when we've split by region, some of these regions don't have very many states in them. So if you look at the South, how many states does the South have with affordable care? So you have to go to your table, go to the top, and it'll give you the sample size. Ooh, someone's popular. You just sold something on eBay.
2.
Right, so here we are in the South, 2007, affordable care. There's only 2 states. Only 2 states. Right? And then for not affordable care, how many does the Northeast have? Only 1 state. Only 1 state. Everyone else is considered to be affordable. So if we look at the figure, see here I've got blue and yellow, and here I only have yellow. So this is totally, for the density curve, it's getting totally swamped by the not affordable. I don't have enough to kind of show the blue for what's going on with the affordable care. Only 2 states there. Right there and right there. Okay? And then for the Northeast, all I have is affordable care. There's only 1 state considered to not have affordable care in the Northeast. I hope it's Jersey. Is it Jersey? I haven't checked. I should see. All right. Anything else that you see here? So these are really good observations. So here I see that the Northeast doesn't have many not affordable health care states. I see that in the South doesn't have very many affordable health care states. I also noticed that in the South, not so much in the other regions, but in the South, it looks like the interquartile range of proportion of kids receiving preventive dental care is a lot wider than it is for the affordable care states.
So does the West have the most affordable?
Does the West have the most affordable healthcare? So for the most affordable healthcare, you'd have to look at the actual rank.
Or
Right, because here the y-axis isn't the degree of affordability. Here the y-axis is proportion of kids receiving preventive dental care. So which region has the highest proportion receiving preventive dental care? Northeast. And is it in their affordability healthcare states or not affordable healthcare states? In the affordable healthcare states. But even in the not affordable healthcare states, right, it's still a little bit higher than the South. It's right at the level for the Midwest here, but it's not higher than that. And it's a little bit higher than the West region for affordable healthcare states. Yes?
So would it be safe to say that it has something to do with like poverty versus, having a lot of money in those states?
It's a conclusion. It's not a conclusion, it's a hypothesis. We don't have data for that yet, but if we collect data, we can associate it here and see if there's a relationship. And if that relationship turns out to be statistically significant, then you might say, I noticed this observation of these differences, and I later tried to associate it with poverty or financial literacy in the area, and those appear to have a significant relationship. So I think this is an artifact, or this is due to the lack of financial literacy or poverty in the regions, right? But now that you have the data to start playing with it to actually build sentences that say, yes, it is or it isn't.
Are we supposed to see the little dots like where each thing is?
You might not see them very well, but inside here is a scatter. Very faintly you can see the scatter, the hint of dots. Now they're covered up by the boxes, and at least in Jamovi, we can't modify this. We can run code though behind Jamovi to lighten up the boxes so we can see these a little bit better. We can run code to kind of provide labels for each of the dots so we know which states they are. But right now, with the options that we have, we can't do that. But yes, there are dots there. Okay. So that's 2007. What do we see in 2011?
Similar pattern would include the
Similar pattern, yeah.
affordable in the West.
That's right. Similar pattern, except now in 2011, the variability for proportion of kids receiving preventive dental care is a lot wider in 2011 for the not affordable health care states than in 2007. So this seems to be something that you might want to focus on as a policy analyst. Let's focus on the affordability of healthcare because it looks like we're getting a lot more variability and it's getting lower, right? So here we are, lowest is just under 75, and here we are in 2011, and it's dipped even further. So when we saw that dip from 2007 to 2011 for the whole U.S. and by region, it looks like part of that dip might be attributed to the lack of affordable health care states. So right around that, the Affordable Health Care Act. So we want this to be addressed by that Affordable Health Care Act. If it's not getting addressed by that Affordable Health Care Act, then we're not sure if it's actually working the way it was intended to, unless these states are different states than where they were 4 years ago.
I have a question.
Yes?
Why is it for the first two you see 2 graphs, but
Yes.
the last two you see only one? Is it like how many peaks you see?
Yes, so it's related to how many states are participating. So we don't see the not affordable here for the Northeast because there's only one state. Can't build a distribution with one state or an N of 1. Even with an N of 2, it's kind of hard to build a distribution. So that's why we don't see them where the N is 1 or the N is 2. All right, that's 2011. 2016 shows us what? So after the Affordable Health Care Act, where is the proportion of kids receiving preventive dental care? It's now, yeah, it's higher. Even among the states that were noted as not affordable health care. So now that access to care has been addressed, the proportion of kids receiving preventive dental states, even in these regions, the healthcare is still not that affordable. We're still seeing a boost in the healthcare outcome, which is what we wanted to see. Okay, so we see that here in the West. We actually, in fact, see a unique artifact in the West. What's happening in the West? Shows the states who did not have affordable health care after access to health care has been made available through the Affordable Health Care Act. What happens to the portion of kids receiving preventive dental care?
Goes up.
It's even higher than in the states that had affordable health care. More kids are receiving preventive dental health care outcome in the states who are participating probably in the Affordable Health Care Act. So although they're still being designated as they don't have affordable health care, they're still being designated as having a better health care outcome in 2016 than those states who had affordable health care. That's an interesting one. Yes?
What's going into the algorithm of the affordability range?
Yeah, that's a fantastic question, and there are a number of issues. It's like a 13 or 12 variable model. You should come to the office and come and sit down and go through that. It's big. It's big. What about in the Midwest? What do we see? Similar artifacts, slightly higher in the states who are tagged as not affordable, right? But still wider variability, so still improvement. What about in the South? All right, so let's get our bearings here. In the South, 2007, okay, yeah. Right, only 2 states there. Here in 2011, only 2 states?
One state covered.
Yeah, still only 2 affordable, right. And now, in 2016, what's happening? This gap, this disparity between the proportion of kids receiving preventive dental care for the affordable health care states and the non-affordable health care states, 2016, it's the biggest we've seen in 2007, 2011, 2016. So the South is a region in which we see the biggest difference in the proportion of kids receiving preventive dental care between affordable health care states and not affordable health care states. So although we see this marginal, maybe real, maybe random improvement in proportion of kids receiving preventive dental care for the West and the Midwest, in the South it's the complete opposite, and there is a very significant disparity or difference between the proportion of kids receiving preventive dental care between these 2 states. Okay, kind of looks like the Northeast, except it's flipped. All of the states, but 2, are over here. Yes.
Since that little line in the northeast, that's the not affordable one,
Yes.
is more inside the blue, does that mean it's more affordable?
Nope, no, it's within the range that we see here for affordability. But we can't, since there's only one state, we can't build this density violin function around it. So you're just gonna see it lumped like this guy. But again, it's a lot harder to try to appreciate this if you're looking at the numbers in the table. If you look at these box plots, it's a lot easier to kind of figure, oh, okay, here are the differences, the trends that I see. And if you want to specify, now you can go back to the table to get the real numbers. Now, we've spent about an hour and a half talking about all this. We don't need to see an hour and a half worth of talking in your assignment. You pick and choose the highlights of what you want to describe, okay? It's very short, it's supposed to be very brief and short. The real exercise is when you've done this together in class. Now you need to take from what we spoke about in class, things that speak out to you or are meaningful to you, highlight those in the assignment and turn the assignment in. Okay? At the last half of this course, this is after the midterm, this is where we start to really become more structured in our responses to what do you see statistically. So right now, this is more of a discussion, everyone getting on the same page.
So you just want a written description, you want us to copy and paste it?
Just mark up the Microsoft Word document that the assignment is in. Okay, so you take figures, if there's a figure you want to reference, copy it, paste it. If there are portions of the tables that you want, copy it, paste it, and do your little 1 to 2 sentences of what you see. This is not supposed to be a long report. Okay? Yes?
So what were we supposed to have read before this class? And it's in the workbook, right?
Right, so central tendency and dispersion. So Cheryl Willard, that's probably chapters 3 and 4. And then in Jamovi, I specify which sections in Jamovi. Now the reading is not something you're supposed to obsess over. It's something you're supposed to spend time with and say, okay, I've read it, I'm familiar with the terminology, the definitions, and what they mean. I'm probably going to hear them again in lecture, but I'll hear them in context now.
So are we supposed to fill out the workbook yet
Cheryl Willard, yes.
with those chapters?
I would recommend that you do it now as opposed to waiting until the end of the course. I would do
So,
that.
is CW?
CW,
Yeah,
Cheryl
okay.
Willard.
Okay.
Yeah, he just posted it. He just posted the CW, like the workbook stuff.
It's in this back
He
there.
updated the syllabus,
The syllabus.
as CW on it now.
Back there.
I see more hands. No more hands? Everyone's afraid to put up hands now. I want this to end. Enough already. Okay, are we good? Okay, so I expect emails from you if you have any questions. I'm going to be honest with you. I respond a lot more quickly if I get an email. Canvas is harder for me because it's another portal that I have to kind of pay attention to. So some of you have been contacting me on Canvas, and I've been trying to do a good job of getting back to you on Canvas. But in truth, if I miss a beat on there, so it's like a day or a day and a half before I respond, it's because it was through Canvas. But if it's via email, I'll get a response to you as soon as possible. But I'm responsible for Canvas, so that's my professional responsibility. I will respond. Yes.
Do you have time today?
I do have time today.
Okay.
What time are you thinking?
Well, we have a class after this, and then after that class, maybe, so.
So noon?
Yes.
Okay, I think so. Yeah, come by at noon. Do you know where they're doing all that construction as you walk over to the student pavilion on the left-hand side? All right, so on your right-hand side across the street, there's a nice-looking motel, old motel, where Research Affairs is. Right across the street is a really crummy-looking old motel. That's where my office is. Okay, it's the old CDR building.
Nice to meet you.
Yes, right next to hers. She is 204. I'm 203. Yes, Professor Hayton, Shelley Hayton. Yeah, that's where my office is. I'm the door right before her door. So if you're wanting to come and do some of this stuff over at the office, just knock on the door, come on in, and we'll get set up in the lab. Okay? All right. I'll see you guys later.
Oh, it's gonna be 100.
Gonna be hot today?
100. That's hot yesterday.
Won't feel so hot for you though.